Hi, I'm Shinobi from Bitcoin Magazine, and I'm sitting here with Andrew Poelstra from the research division at Blockstream. We're going to talk a little bit about Rusty's insane plan to turn all of the opcodes back on. So it's a really ambitious plan that Rusty laid out, and pretty much turn back on everything that Satoshi turned off due to the denial of service risk that he figured out early on, with some new resource budget limits to try to address those issues, and a few other pieces just to kind of avoid the ugliness of trying to hack together covenants with just cat alone and a few other pieces. So what's your take on this? Like, do you think this is a good direction to go and something that we can actually feasibly build consensus around?
Yeah. So I don't know if Rusty published this or anything before this conference. It was kind of the first that I heard about it was yesterday morning when he did this. And I think probably he was kind of intending that, right? It's a bit of a surprise. Mm-hmm. Overall, I'm in favor of it. I have a couple thoughts. So one is, the new costing model is very interesting, and it's kind of a departure from the way that Bitcoin works today, kind of, right? So right now in Bitcoin script, every opcode kind of costs one. And it costs one weight. It takes a byte to encode. We have the transaction. You have to pay per byte. Some bytes are worth more than others, but you pay per byte. And your script opcodes all are 1 byte. And then in the old pre-Taproot days, we had this additional limit called SIGOPS because we realized that this byte model just didn't work, right? Mm-hmm. It didn't work for signature checks because they were so wildly more expensive. But then with Taproot, we kind of went back to that. We said, well, it's true that a SIG check is way more expensive than a hash, which in turn is more expensive than every other opcode. Mm-hmm. But a signature check already requires that you stick a public key and a signature onto the stack. And so why don't we just kind of make it a requirement? Say every signature check, you just have to have 50 bytes of data somewhere in the transaction. And if you're doing a normal signature check, well, you already have that. Your public key is 32 bytes. Your signature is 64. So there you go. You already got it. Mm-hmm. And it's only if you're doing something crazy, like you're using opt-up to duplicate you write a pub key once and then duplicate it a bunch of times and then do a bunch of check sigs as the same thing. In that case, you could, in theory, do 1,000 check sigs with 1,000 bytes. And there, the Taproot rule saying, well, every one of those needs 50 bytes somewhere, mm-hmm. steps in and prevents you from doing that. And so what Rusty is doing is kind of making all the opcodes work this way, right? So in our Taproot modeling, we took I think the way we got this number 50 is by comparing a signature check to the SHA-256 opcode, saying, well, SHA-256 is the most expensive opcode of all the existing opcodes, and we'll just treat that as our prototypical opcode. Mm-hmm. And because we have a 520 byte stack size limit, we can think of SHA-256 of 520 bytes as the most expensive thing. It's a little inaccurate, right? Using that worst case as the value of a single opcode. But we can get away with it because right now, we have a limit. We can say that's the most expensive. Everything else, worst case, we overcharge for it. Mm-hmm. Fine. Rusty wants to have arbitrary size, variable size arithmetic, right? He wants to be able to say, you can add two numbers, whether they're 32 bits or whether they're 256 bits or whether they're 10,000 bits, right? You can add them, and we got to figure out how to cost that. So now, all of a sudden, well, for one thing, we don't have a worst case, right? You can't say, well, SHA-256 of 500 bytes is the worst case, right? Because you could be hashing arbitrarily large things. Mm-hmm. And secondly, even if there was a worst case, it would be way worse than something small, right? Yeah. You can't just say, well, every opcode costs the same as hashing a megabyte, right? You could say that, but then the script would be useless because everybody tried to do anything. Mm-hmm. So instead, he's looking at every opcode. He's looking at the actual values on the stack that it's computing with, and he's computing the weight that way. And I'm going to say something kind of mean here and say this looks like gas, right? This looks like gas in Ethereum, where you now have a transaction, it's got a size, it's got a weight, you compute it, and your weight now kind of becomes like a gas limit. Mm-hmm. And so when you execute your script, you might, in theory, run out of gas. And so this makes it difficult. Well, All right, let me try to untangle several wrong things with Ethereum and show why it doesn't apply here, but show why it's reasonable to be a little, like we need to talk this out in public and write some things down and nail down our design decisions here. So one issue that comes to mind is now when you see a transaction in the mempool, you can calculate its weight and you know what the maximum gas cost. I'll stop using that word. I'm just being, that's too mean. That's mean. All right, so you know what the limit is of the script resources that you're allowed to use. But then to tell whether or not your script exceeds those limits, you need to actually execute the script.
Yeah.
Right. And with scripts that can do complicated things, that's maybe a little worrisome. But the truth is that this is already kind of possible in Bitcoin today, in that you can write a very complicated script that does a whole bunch of check sigs and so forth, and at the very end it does like zero verify, which will fail, or op return, which directly fails the script, right? And so a validator needs to run through the entire script, and then they're going to, at the end, realize the transaction is invalid and throw it away. So that's something that, independent of what Rusty's doing, just by relaxing the script limits in Taproot and generally relaxing the limits on what script can do, we're going to have to come up with some static analyses and some heuristics to make sure that you can't spam the network and sort of stuff into the mempool. And our peer-to-peer ban rules also address things like this. I believe that's currently, I don't want to commit to this on camera, but I think that the current ban rules in the peer-to-peer network are such that if you were to try that, your node would just be banned, and then you'd quickly find that nobody will accept your spam transactions because you can't connect. So that was my first thought, right? Is now we're kind of changing the costing model to be something where you don't know whether you're going to run out of script execution time until you actually run the script. Yeah. But we already have that with op return. And really, there's no avoiding it. That's just kind of the nature of having an open-ended script, is that you can't, unless you were to completely rewrite the script system and do something like simplicity or perhaps ChiaLisp, where your language is designed from the very start to have statically computable bounds on all of your resource usage, you have to live with this, right? And any stack-based, kind of opcode-based stack manipulation language like script is going to have to deal with this.
Well, I mean, and there's one, I think, silver lining here, at least just in a basic case. Like, unlike Ethereum, you can't run into this problem and then still have a transaction confirm and cost you money. It just fails and your money's fine. Yep. So really, the only risk I see there is if you have a situation like that occur in like a layer 2 like challenge response protocol, and you're not able to complete the protocol. But just in a basic, like, I'm using a very complicated script, like you're not going to just make a transaction that fails to complete and yet still cost you money.
Right, exactly. And so that's why using the word gas is a little bit mean, right? Because that is a critical difference, which in that is that on Ethereum, for other design reasons related to their account system and transaction ordering and so forth, if you run out of gas in Ethereum, the transaction still has to be valid, and it still goes into a block, and it just burns all of the money that you would have spent, right? And that's not the case here, right? As you say, if you are writing a script and it exceeds whatever cost you're allowed to exceed based on the size of your transaction, then the transaction is just invalid, and it gets dropped, and you can try again. So the concern then becomes a wallet trying to design a script, can they bound what their potential cost is going to be and make sure that their transaction is large enough? And the answer is yes, right? Because when they're constructing their script, it's possible to get a static bound on the maximum resource cost. Like no matter which if branches you take, no matter what you do, you can get a static bound. And Rusty probably didn't mention this to you because I think he figured it out this morning, but it turns out that there's a pretty easy, reasonably accurate, easy to compute bound that you can do with the system for everything except for the left shift opcode. So if you are a wallet author doing some like general miniscript type thing, you probably need to avoid that specific opcode, unless you're writing like a custom script that you kind of manually out of band do some analysis on. So that's pretty good. That's pretty good that every opcode except for that one is something that wallets and script authors can wrap their heads around and do static analysis.
It's good news, I'll say. Definitely. So like really in terms of like practicality here, do you see a path forward where at least amongst developers, like we can kind of build consensus around this and kind of start moving forward in implementing and testing it? And if so, like, how long do you think that would really take to kind of get the ball rolling?
Yep. So the first question is, can we do it at all? And I think the answer is yes. There's been a really interesting kind of mood shift in the Bitcoin developer community over the last 6 months since Ethan and Armin posted the opcat BIP. And where the shift is coming from is that, a couple of years ago, like in 2020, 2021, when we were talking about OpCTV and other related things, there was kind of a push where proposals were trying to narrowly scope themselves and try to say, well, we want to enable specifically non-recursive covenants without giving you open-ended script expressivity and general covenants and stuff like this, because there's a lot of fears around covenants where people don't want people to create NFTs and to do weird stuff on the Bitcoin chain. And in the intervening time, for one thing, people just kind of got tired, right? They're like, well, we have all these different narrowly scoped proposals and none of them are getting a whole ton of mind share. And a lot of us would really just like to be able to do everything. And we're not going to decide on which narrow thing, and like, let's just do it. Mm-hmm. And then another thing that happens is ordinals showed up and the inscriptions showed up, really. And that, I think, indicated to everyone that for better or worse, this is happening, right? Like adding opcat and adding covenants are not going to be the difference between a world where Bitcoin is only used for Bitcoin and a world where it's not, right? Like bluntly, if people want to do this, they're going to find ways to do that, and we need to trust that the economic incentives surrounding it are going to sort things out so that, legitimate Bitcoin usage for whatever you think means legitimate is going to be priced higher than trading things like NFTs and whatever. Mm-hmm. And I think for the specific case of ordinals and inscriptions, that will be borne out. I mean, the market can stay irrational longer than we can stay solvent. You can never actually bet against it, but these things are worthless, right? I mean, they're just JPEGs that are on the chain, and it's kind of a fun meme, and people are bidding this up. And we've seen this happen before, right? We saw this with the NFTs on Ethereum, where there was a wild market in 2021.
Counterparty, right? Back in like 2014.
Before that, yes, Counterparty was another example of doing this on Bitcoin. Before that, we've seen like Satoshi Dice was not like an asset that you were trading, but it was a thing that used a lot of Bitcoin block space where people got really into it, they got hyped up, the fee market increased, that made Satoshi Dice insolvent, and they basically shut down because of that, right? Mm-hmm. So these things have happened in the past, they'll happen in the future. They're short-lived, right? I mean, they'll live longer than I think a lot of people want them to live, but they will live. And CAT is not going to change whether that's, or any covenant proposal is not going to change whether that's the case. Mm-hmm. The other fear is that, well, the thing about ordinals is that it's kind of a way of looking at the existing UTXO set, right? If you want to count UTXOs and like order them, and okay, you can do that, but it doesn't affect anybody else. Mm-hmm. People worry with covenants that you would use script to like enforce to say, well, this zero values UTXO needs to remain zero value, but it's going to have to encode some particular tag or whatever that will cause it to be permanently marked as an NFT. And now you have actual NFTs trading on the actual chain, and it's not just a matter of perspective.
But I mean, does it really matter whether you explicitly encode like a meta protocol or just view it from the application layer? Like, it's still ultimately the people who want to do that are going to do it. It doesn't really make a material difference, like which mechanism you use.
I think that you're right. And more importantly than the people who want to will do it. I mean, they'll do it for better or worse. The fear, I think, was that people who don't want to will somehow be forced to go along. And that's just not the case, right? If you don't want to participate in these kind of markets, then if you don't run a wallet that has a whole bunch of explicit code designed to support these things, then you won't. You won't recognize these as valid Bitcoins, or you'll recognize them as zero value and not accept them. You won't be able to spend them without a wallet that supports it. And you can basically ignore it in every way except maybe for the effect on the fee market, mm-hmm. right? So that's another thing that's kind of shifted is now that we have this tangible example of inscriptions and also have had a bit of time to think about, like, realistically, what's the attack model behind these general purpose covenants. And we've had some time to get frustrated about nothing happening, right? You know, things are shifting. And another big thing maybe that changed was the introduction of opcat as a BIP. And so the kind of cool selling point in my view of cat is that it's a very simple, narrowly scoped opcode. It's 5 lines of code, and most of those are very straightforward sanity checks. There's really 1 line of code that does the actual concatenation. Mm-hmm. And it gives you all of this expressivity for this one, like, kind of cheap edition where there's no room to bike shed. There's no room to be afraid that this is opening some obscure consensus bug or has crazy edge cases or something, because there's no branches, right? But the branches are like, if there's nothing on the stack, fail. You know, if the stack item is too big, fail.
Yeah,
you know?
the only concerns are all second order. Like the actual thing itself is the simplest thing that could be.
Yeah. And then what caught me off guard is cat became a meme, right? Like there's really a whole ton of activity in the Twitter sphere and Telegram and all these places that I'm not present, but I pay people to tell me what happens there. And it really took off as something that people got excited about, and got excited about script expressivity in general. Mm-hmm. And that puts us in a place where maybe we could do more than cat, right? Like maybe we could reopen all of the old script opcodes, because they're all of the disabled opcodes are pretty small. As Rusty was saying during his talk, they're all comparably simple to opcat. There's a lot of them, there's a dozen or so, but they're all very simple, they're all easy to scope, they're all easy to reason about. None of them are going to cause weird edge cases or things to explode or anything like that. And really, the biggest thing to be afraid of is this new script costing model, right? And even that's very simple, right? Mm-hmm. There's a straightforward table. You look at the size of your stack items, you multiply it by some sort of fudge factor for every single, not a fudge factor, but an explicitly calculated cost factor for each individual opcode. And so somebody has to read through whatever BIP he winds up getting and make sure that those factors all make sense. So that's not so bad, I think.
And I guess, just to kind of wrap stuff up so we don't get soaked here, like, do you have any final thoughts on, like, just kind of how to move forward here and kind of handle this in a constructive way, rather than have this become a wedge where you just have, on one hand, people trying to move forward, scaling things, and the other half people just scared and hesitant to move forward in any direction?
Yeah, it's a good question. So initially the steps are pretty straightforward, right? You write up a proper proposal, you have a reference notation, you write test vectors, you get benchmarks, like all of the mechanical stuff are things that Rusty or somebody still needs to do. We open a PR to the BIPs repo, we get a BIP number. Fortunately, that's fairly straightforward now. We have a number of new BIP editors, and there's been a lot of discussion in general about to what extent should the BIP editors be trying to filter ideas for whether they're something that they would approve or something that's a good direction for Bitcoin. My opinion has always been that, like, everything should get a BIP. Like, I don't care how bad it. You could propose a BIP to, like, do infinite inflation, or a BIP to just, like, stop Bitcoin at block 1 million, or a BIP to whatever. And, like, as long as it's well specified and meets the formatting rules and has tests, it should get a number, right? Like, a BIP number is not approval or a sanction.
It's just a repository of ideas.
Yeah. So fortunately, that will be pretty straightforward. And then we have kind of an anchor, right? The benefit of having a BIP number, as you can say, is BIP 123 or whatever, and you can talk about it and all agree on something. And once you have a BIP number, there's also a bit more resistance to changing the idea. So you don't necessarily get into these kind of bike shedding things. They have an open-ended, like, design goal where everybody's referring to this, but everyone's talking about a slightly different variant, and nobody quite agrees on what specific opcodes and what the limit should be and blah, 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 right? Like, you kind of have something that you can coalesce around. And then after that's the hard part, right? Then you got to think about getting consensus, getting people to agree. You got to talk to people who identify as ossificationists, or we might call ossificationists, right? People who don't want Bitcoin to change. And I think we just got to argue passionately and correctly that this is something that would be good for Bitcoin. It's good for everybody. It won't force anybody to do anything, and the things that it enables that maybe people don't like because they're distortionary to the fee market or whatever. For one thing, we're really on the edge of enabling those things anyway, and possibly already on the wrong side with the existing. But secondly, the things that it enables that are definitely good for Bitcoin, which are things like vaults, and the ability to rate limit, and the ability to do what are called like coin pools, where an exchange does multiple withdrawals in one UTXO, and then the recipients get to pay fees and choose their timing and stuff. All of those are really important for Bitcoin. Oh, and L2 and Lightning, like fixing the Lightning storage requirements where you have, you know, linearly growing storage, and if you lose any part of your old transactions, then suddenly you're vulnerable to somebody publishing an old state, so you need to add these watchtowers and stuff, and the whole thing has these scaling limits. Well, we need new opcos to fix that, right? So I think over time we'll be able to articulate these things, and people will come around, I hope, right? And that's where we're at.
All right, well, thanks for sitting down and talking, Andrew.
Thank you.
It's a pleasure, and I hope everybody enjoyed.
Yep.